All right, boys and girls, if you could follow along, we're going to finish up the first lesson of chapter 1 on what scientists do and make good hypotheses. They have to be good at making good observations, drawing conclusions, all in this lesson. So we left off on how we write a good hypothesis. Now we're going to continue on page 10 that scientists have to be very good at making observations. And that doesn't mean just using sight. So please follow along, page 10. Scientists use many skills and processes to find answers to problems. One of these is making observations. An observation is something you find out about objects, events, or living things by using your senses. Scientists make observations very carefully. In this way, they can be sure that the information they gather is reliable. Think about having a reliable friend. It's something you can always count on. Scientists often use tools, such as thermometers, to extend their senses. Scientists are also good at organizing their observations. When scientists have collected their information, they analyze and evaluate it to draw a conclusion. They also share their findings with other scientists, who can then see if their own results are similar. For example, scientists may have observed that a group of sea turtles returns to the same beach every year to lay their eggs. The scientist wants to find out what causes the turtles to return and where they go between the yearly beach visits. Scientists used identification tags and radio transmitters to observe that a sea turtle might travel thousands of kilometers in 1 year and return to the same beach. So if we look at the question on page 10 where it says analyze, the scientist below is observing a sea turtle. What problem might the scientist define, and how might she find some answers to her problem? So for instance, maybe they observe the sea turtles not eating very much. So they observe that and then they turn it into a problem. Why isn't the sea turtle eating very much? Did something happen in its habitat causing it to have less food to choose from in its population? So first, it could be just a general observation. It doesn't have to be on the color of the sea turtle or something you physically see. It could be just something you're observing in nature. And then that scientist turns it into a question that he or she can physically research and create an experiment. They also need to be good at drawing conclusions. So follow along on page 11. Scientists then use their observations to draw conclusions. When they draw a conclusion, they summarize what they've learned by analyzing their observations. For example, a scientist might observe that some populations of birds that eat certain fish are decreasing. The scientist may then observe that the fish have been dying. By testing the properties of soil samples from the riverbed, the scientists may be able to observe qualities of the soil, such as the presence of pollution. Using this observation, the scientists might conclude that pollution in the river is causing the living things there to be unhealthy and to die or move away. So it's not just coming up with observations and um, creating an experiment, but then in the end, they have to look at, was their conclusion accurate? Was it not? And what caused these results to occur? This is all part of being a good scientist, that you create good hypotheses, you make nice general observations by using all of your five senses, creating a problem that is testable, talking to other scientists to make sure that your results are reliable and consistent.